Let us take a look at some more examples on applications of trigonometry. Example: a tower stands vertically on the ground, from a point on the ground, which is 15 meters away from the foot of the tower. The angle of elevation of the top of the tower is found to be 60 degrees. Find the height of the tower. Answer. Let us consider a simple figure to represent the problem. Here, in right-angle triangle ABC, which is right-angled AB. AB represents the tower. BC is the distance of the point from the foot of the tower. And angle ACB, that is, angle C is the angle of elevation, pointing towards the top of the tower. Now, we need to find out the height of the tower AB. For solving the problem, we need to consider the trigonometric ratios, such as tan C or cot C, as the ratios involves AB and BC. We have tan C equal to AB by BC. Since tan C equal to side opposite to angle C by side adjacent to angle C, we know that angle of elevation angle C equal to 60 degrees. Therefore, tan 60 degrees equal to AB by BC. Here, BC equal to 15, which is the distance from the foot of the tower to a point C. This implies that tan 60 degrees equal to AB by 15. We know that tan 60 degrees equal to root 3. Therefore root 3 equal to AB by 15. This implies that AB equal to 15 root 3. Therefore, the height of the tower is 15 root 3 meters. Let us see an alternate method to find the height of the tower. Alternate method. In triangle ABC, right-angled AB. Consider the height of the tower as h. Distance from the point on the ground to the foot of the tower as d, that is, d equal to 15 meters. And angle of elevation theta equal to 60 degrees. Since tan theta equal to opposite side by adjacent side, we have tan theta equal to h by d. This implies that h equal to d tan theta. This implies that h equal to 15 into tan 60 degrees. As we know that tan 60 degrees equal to root 3, we have h equal to 15 root 3. Therefore, the height of the tower is 15 root 3 meters. Example: an electrician has to repair an electric fault on a pole of height 5 meters. She needs to reach a point 1.3 meters below the top of the pole. To undertake the repair work, what should be the length of the ladder that she should use, which, when inclined at an angle of 60 degrees to the horizontal, would enable her to reach the required position? Also, how far from the foot of the pole should she place the foot of the ladder? You may take root 3 equal to 1.73. Solution. If we observe in figure, the electrician is required to reach the point B on the pole AD. Here, pole height AD equal to AB plus BD. We know that AD equal to 5 meters and AB equal to 1.3 meters. This implies that 5 equal to 1.3 plus BD. Therefore BD equal to 3.7 meters. Here, BC represents the ladder. We need to find its length, that is, the hypotenuse of the right triangle BDC. So, we have to consider the trigonometric ratios, such as sin C or cosecant C, as the ratios involves BD and BC. We have sin C equal to BD by BC. This implies that sin 60 degrees equal to BD by BC. We know that sin 60 degrees equal to root 3 by 2, so we have root 3 by 2 equal to 3.7 by BC. Therefore, BC equal to 3.7 into 2 by root 3. BC equal to 4.28 meters, approximate. Therefore, the length of the ladder should be 4.28 meters. Now, we need to find the distance DC. That is how far from the foot of the pole, the foot of the ladder should be placed. For this we need to consider the trigonometric ratios such as tan C or cot C. Since we know that tan C equal to side opposite to angle C by side adjacent to angle C, we have tan C equal to BD by DC. This implies that tan 60 degrees equal to 3.7 by DC. As we know that tan 60 degrees equal to root 3, we have root 3 equal to 3.7 by dc. This implies that dc equal to 3.7 by root 3. This implies that dc equal to 2.14, approximate. Therefore, the electrician should place the foot of the ladder at a distance of 2.14 meters from the pole. This problem can also be solved using another method. Let us see an alternative method. Consider the height of the pole is h equal to 5 meters, and the point to reach below the top of the pole to undertake the repair work is h1 equal to 1.3 meters. And the remaining height of the pole, h2, which need to be found. From the figure, we can observe that h equal to h1 plus h2. This implies that 5 equal to 1.3 plus h2. This implies that h2 equal to 3.7 meters. To find the length of the ladder, that is L, consider the right triangle BCD, and angle of elevation theta equal to 60 degrees. Considering the trigonometric ratio sin, we have sin theta equal to h2 by L, since sin theta equal to opposite side by hypotenuse. This implies that L equal to h2 by sin theta. This implies that L equal to 3.7 by sin 60 degrees. We know that sin 60 degrees equal to root 3 by 2. We have L equal to 3.7 by root 3 by 2. This implies that L equal to 3.7 into 2 by root 3. This implies that L equal to 4.28, approximate. Now, we need to find the distance at which the ladder should be placed from the foot of the pole. So considering the trigonometric ratio tan theta, we have tan theta equal to h2 by d, since tan theta equal to opposite side by adjacent side. This implies that tan 60 degrees equal to 3.7 by d. As we know that tan 60 degrees equal to root 3, we have root 3 equal to 3.7 by d. This implies that d equal to 3.7 by root 3. This implies that d equal to 2.14, approximate. Therefore, the electrician should place the foot of the ladder at a distance of 2.14 meters from the pole. Example: a circus artist is climbing a 20 meters long rope, which is tightly stretched and tied from the top of a vertical pole to the ground. Find the height of the pole if the angle made by the rope with the ground level is 30 degrees. Solution: here, A, B represents the pole. AC is the length of the long rope tied from the top of the pole to the ground, that is, AC equal to 20 meters. Angle ACB is the angle of elevation, and angle made by the rope with the ground level is 30 degrees, that is, theta equal to 30 degrees. We need to determine the height of the pole AB. We know that AC equal to 20 meters. Theta equal to 30 degrees. To determine AB, we choose the trigonometric ratio sin theta, as the ratios involves both AB and AC. From triangle ABC, we have sin theta equal to AB by AC, since sin theta equal to opposite side by hypotenuse. This implies that sin 30 degrees equal to AB by AC. As we know that sin 30 degrees equal to 1 by 2, and AC equal to 20, we have 1 by 2 equal to AB by 20. This implies that AB equal to 20 by 2. This implies that AB equal to 10 meters. Therefore, the height of the pole is 10 meters. This problem can also be solved in another method. Let us see an alternative method. In triangle ABC, right angle AB, consider the height of the pole is h meters. And length of the rope is L, that is, L equal to 20 meters. And angle of elevation theta equal to 30 degrees. From triangle ABC, we have sin theta equal to h by L, since sin theta equal to opposite side by hypotenuse. This implies that h equal to L sin theta. This implies that h equal to 20 into sin 30 degrees. As we know that sin 30 degrees equal to 1 by 2, then we have h equal to 20 into 1 by 2. This implies that h equal to 10 meters. Therefore, the height of the pole is 10 meters.